Welcome everyone. Today's webinar is FactoryTalk 2.0 Overview and Introduction. During the event, you can use the left pane to navigate between chat, handouts, and other event information. Please feel free to submit any questions you want answered live through the chat window, where the moderator will respond or bring them to the attention of the presenter. For those who want the presentation display to be larger, there is a full screen option. Files for this presentation are available for download on the handout screen represented by the paperclip icon. Today's presenter is John Cochran from Revere Electric. John is Revere's Mechatronics business lead and has been with Revere over 15 years with over 35 years of experience in motion applications. I, Tom Roth, Technical Solutions Consultant for Revere Electric, will serve as moderator for this event. Take it away, John.
Hey, thank you, Tom, and welcome everybody. Yes, today, so what we're going to do is just kind of an introduction and an overview on the new FactoryTalk Motion Analyzer 2.0. And before I get started, just wanted to quickly just mention that basically Revere Electric, we are a complete mechatronic solutions provider. So if you have any type of applications, any type of motion applications, feel free to please contact us or reach out to, either your account guy or any of the motion specialists that we have on staff here. We have a couple motion specialists in Illinois, including myself, and as well as couple motion specialists as well in Wisconsin. So we can definitely service and provide all of our customers whatever mechatronics needs they have. Just a quick note here, just kind of showing some of the solutions we have today. And we're going to talk about all the servo sizing, but to go with the servo sizing, we have all the different mechanism types, the different transmission types that are available as well. So keep that in mind if you have an application that you're thinking of. Maybe it's a robot application or a conveyor indexing application or whatever your motion needs may be. Please give us think of Revere Electric as your one-stop shop for mechatronics. Oh. So what I'm going to talk about today is typically in the motion applications, our normal thought process is that we are looking for a certain size drive, certain size motor for a particular application that a customer may have. And what we like to really do with the way the workflow works with the motion analyzer with the sizing is that we kind of flip it around and we actually take a look at the application requirements first. So we're looking at all the mechanics, all the performance requirements, things like that's required for the application. Once we get the application details, and then in the motion analyzer I'll show you today, we're going to run through, actually do a sizing, and we'll then go through and we'll select our transmissions, our motors, and then the drives lastly. And as we look deeper into the applications with our customers, each application is unique. So for each axis, we have to basically go through and do this, and they're each basically sized separately. And that's regardless of the kind of application or which of axis of the application that you're sizing, they'll fall into a specific section of your sizing procedure that are imposed by the mechanics of your customer's application and the performance requirements that are achieved for the axis. So we'll go through that today and talk about all the different type of mechanics that are available in the sizing software. And again, what type of performance requirements that we need in order to help size the axes. As far as the software, the FactoryTalk Motion Analyzer 2.0 is available on Rockwell's download website at the PCDC. And here's a QRC code they can also get to get to it, or the link below that I've got here as well. So you can download the software. It is available for free. There's no cost for the software. If you have any questions or need help with that, just feel free to reach out to us as well. The FactoryTalk Motion Analyzer, some of the key capabilities I want to talk about today is basically being able to select, analyze, and store the projects offline. So this is one of the biggest changes. Some of our customers in the past have been using the Motion Analyzer online version, and now Rockwell has gone to this new offline version, which allows us to save the projects, onto our computer or be able to share them, email them. Where in the past they were just online only, and we would have to basically share access to those projects online. The solution search will get a lot into that as well, and that'll show you basically once you go ahead and enter all your application information, your mechanisms and transmission, and we go through the step by step. The solution search will basically go through and show us a list of different options that are available based on our application requirements. The analysis capabilities, you can go through then and look at our bus. If we have say a vertical axis, an overhauling load, we may care about the regen. So there's some additional tools as well in the FactoryTalk Motion Analyzer to take a look at that as well, and I'll show you that in the software today as well. There's an extensive product library, so it shows you all the latest up-to-date motors and drives that are available, as well as our technology partners, such as all the different gearboxes that I'll show you as well. And maybe some specialized motors if you have like an explosion-proof application or something like that as well. All those motors are going to be listed in the product library as well. You'll see that they've gone through a simplified user workflow, so I'll show you that today. It's very more effectively showing how the workflow is, and it's a very intuitive user interface for our customers to use. And then we'll also get into kind of the different motion types and the application templates that are available in the software as well today. For those people that maybe are used to using the online tool, there are some similarities here. The application templates are available now in 2.0. The component and cable configurator, that is not available yet in 2.0. So what we can do is export the XML file, is what they're showing here, and then we can actually import that into the online version that has the component and cable configurator. So if you need to finish the complete part number for the motor, the drive, and the cables, you can bring that into the online. And then also we can then export that to Proposal Works, where we may want to get a complete bill of material put together for all the different components as well. Then basically delivering the machine designs do more. So, when we get into Motion Analyzer, we're constantly trying to optimize the solution to get you the optimal performance for, the drive size, the motor size, the gearbox ratio, and we can do all the what ifs for the different application if we find out that the application requirements may have changed or performance has increased. This tool can be reused. You can copy, paste axes. So if you need to quickly look at different scenarios, you can do that as well with the software. You can also enhance the lifespan capabilities of your gearboxes and things like that, all your mechanical components, and as well as take a look at the energy efficiency that you're utilizing on the application. Here I'm going to talk about, and when we get into the software, you'll see different type of mechanism types that are available in FTMA. You have rotary, rotary complex, and then linear. That includes also custom type of mechanisms that we'll talk about as far as like a ball screw or a belt drive or rack and pinion that may be available, as well as the linear actuators that Rockwell offers as well. There's also different type of linear actuators, linear motor actuators. There's linear rod style actuators, things like that. So I'll show you that in the software as well. And then the profile editor, you really go in at this point here is where you really define your application, your cycle profiles. So here's where you actually would go in and put in your performance requirements. So I'm going to, maybe have a cycle rate of so many cycles a minute. I need to move this far, this distance in this much time. I may have a dwell time in between. So this is where you go in and actually put in all those details of your application for, how the motor is going to move and, how far, the distance and time. You can also import cam profiles from Studio Logix 5000. So if you're using Studio 5000 Designer, you can create a cam profile there, import that in, and we can go ahead and size it based on the cam profile as well. And then from there, we also have some tools that are involved with this as well. And one is the inertia calculator. In a lot of cases, we may not know what the inertia is of a particular component. So there is a calculator built in so that we can go in and calculate like what the inertia is of, say, a ball screw or a pulley, and understand what the inertia is, which is important for the servo sizing aspect of it as well. And then we look at the different type of motion components. You'll see the latest components that are supported, all the different kinetics, servo motors that are available, whether it's a standard application, just a regular black paint motor, or whether you need a food grade or wash down, explosion proof, all the different type of motors will be available in the sizing tool. The drives, if you look at the kinetics drives, we have anything, all the different power flex drives, along with all the kinetic servo drives, the 5100, 53, 55, and 5700 are the latest drive offerings from Rockwell. And then, as I mentioned, the linear solutions, you'll see the different stages that are available. If you have a high performance application that requires a high speed actuator like a linear motor. And then gearboxes as well. We have 4 different gearbox partners that are available in the software, and that would be Stober, Wittenstein, Apex, and Shimpo are the partner products that we have for the gearboxes. And then this is basically, again, when I show you the software, you'll see the different solution search. So the software will go out and look based on all your application requirements. It'll start looking for, particular drive size, the motor, the gearbox ratios, and it'll try to optimize, different solutions. And then you'll basically get a list. And, you can sort this list however you need to. But I'll be showing you today on the list. And then once we select an option, say on the list, then what would come up is the axis analysis. And this is where you would actually view your selected motor and your drive, and you can compare it against your calculated requirements. And, you can take a look at your thermal models, you predict your motor winding temperature, make sure that everything looks good there, your inertia mismatch, things like that. And then, from that standpoint, we would basically do a power analysis. Like I said, if you had a vertical axis or something like that, where we would have some regen that we'd be concerned about, we may need to add a shunt resistor or something like that for the bus. We can also do the power analysis that I'll show you today as well. The system outputs, basically, this is once you've selected your solution, you can create a bill of material that will give you a complete bill of material for the motor and the drive for each axis. Like I said, you can export that then to a CSV file, import it in the proposal works, or through the online tool if you want to complete the cabling and the motor and drive options. You can do that as well. And then there's a project report. So if you want to put this in a file for the machine or later time, or send this to a customer, you can, there's some detail for the project report, because maybe somebody doesn't have the software itself, but they still want to see the sizing, the project report on what was sized. And then basically from just comparison from the Motion Analyzer online, you'll see that the file formatting is similar. You can import and export projects between the two versions easily using the XML format. You have sizing and selection. These tools will look very similar. So if you are already familiar with working with Motion Analyzer online, you'll find that the FactoryTalk Motion Analyzer 2.0 has the same look and feel. What you'll find that's different from the online is basically it's got a little bit more simplified workflow, and does have an updated inertia calculator tool that's in here as well for the 2.0. And what I was going to do today is go through an application example here. And what I have here is a customer, say, for example, that's given me an application to look at for an indexing conveyor. This is a very typical common application that we size a lot. So basically the customer's data is below here, where I've said, okay, I've got a load weight of 100 pounds. I've got some belt weight with some loads on it. The coefficient of friction he's provided. The customer's giving me the distance, telling me that this has to index 24 inches in a half a second. No dwell time, and main pulley, what the pulley diameters are, and the idler pulley would be the same as the main pulley. So at this point, what I can do is I'm going to pull up Motion Analyzer FactoryTalk MA 2.0. That's on my computer right now. So when you get into the FactoryTalk Motion Analyzer and you open up, this is the screen that it's going to look like your first screen that you come to. You'll have a library. So example, if you're used to the online, you'll have a library of different projects that maybe you've already sized in the past. But if you just loaded the software for the first time, obviously there wouldn't be nothing in the library. So, as you start creating your projects, they would be saved here in the library. You can also import projects. So you can see there, you can import a project if you've got a project either from an online version, or, if you save something from a past, or a customer sent you a file that they may want you to verify or check or modify. You can also import projects here as well. So I'm going to go ahead and start with a new project and just kind of give you kind of the workflow. The way the workflow works is actually just goes from the top and then starts working down through the bottom. So as the first thing I would do is double click on preferences. And this is where I would go in. For example, if I had a customer information that I wanted to put in his, contact information, address, etc., I would put that in there. And then the site. So this is more like a global type of variable here. If I wanted to say I was working on an application that was up in a high altitude application, I may want to put that in just so that my thermal models and things are correct for the motors. And then the use, you can enter, if you wanted some information as far as what industry and application it is, you would enter that information here as well. So then the next step is basically going through the architecture overview. That's the next field down. And basically at this point here is where I would actually go in and either add an axis or add a bus up to the right here. So the first thing I want to do is actually just add an axis. I can add the bus later. So it's depending on how you want to work, but typically you'll do your axis layouts first, and then I add the bus typically last. So for example, I'm going to go ahead and create a new axis here for this application. And right now, just defaults, it calls it new axis 1. If I want to change this, I can just call it, and say, for example, I want to call it index conveyor. Maybe I've got multiple axes on the machine, and they have different names. So I would just go ahead and create the axes here and along with the axis name. So then you'll see once I create that, I've got over here, I've got either the pencil button, this is the edit button to go in and edit that axis, or I got more actions here. I can rename, duplicate, delete. So again, I can copy and paste. If I had 3 axes of the same, I can quickly duplicate those and not have to go in and re-enter all the information 3 times. So I've got an axis here created for this index conveyor, and I'm going to go ahead and hit edit. And the first thing that shows up is this motion definition, and I can either set up the axis or edit profile. So I'm going to actually go over, and I see the begin button there, and I'm going to start there. And the first thing it's basically asking me is, what type of motion type do you have? So actually we are taking a rotary motor, but we're converting it to linear type of motion with this application, right? So a conveyor, we actually consider that to be a linear type of device. So I'm going to be programming my moves and everything in a linear type of dimensions. So I'm going to go ahead and just set up a linear axis at this point. But if I had a rotary, say I had a rotary like index table, you can see there's different type of rotary, or rotary complex, maybe an unbalanced load, a winder, unwinder, different type of axes that you may have for like a rotary knife or something like that. But for this application, it's going to be a conveyor, index conveyor. So at this point, here's my profile editor. So at this point, I've got to have the information for the application as far as what I need to do, what is the load, what's the mass, all the different things that the application requirements have told me again. So when I go back, if I look here and I look back at the machine data, the first thing I'm going to do is take a look at the move time, and it's telling me I got to move 24 inches in half a second. So when I go ahead and I'm going to add a segment here now in the profile editor, this is like a multi-segment editor, so I can enter in indexes, cams, dwell times, whatever I need to make a multitude of different segments I can put together. So for example, the first thing I'm going to have is just an index, and what it defaults to is basically a trapezoidal profile, which is basically a 1/3, 1/3, 1/3. So it accelerates. You can see here the motor is accelerating for 1/3 of the time. It's cruising, it's at constant speed for 1/3 of the time, and then it's decelerating for 1/3 of the time. Now I haven't given the time or anything like that, so I'm going to go back and just verify what it said. It said move time half a second in 24 inches. Okay, so down below is where you can actually go in and put more specifics and then for that type. So here again, there's my segment type as an index. My index type is a trapezoidal. If I want it, I could put a triangular profile on here, and then it would be accelerating for half the time and decelerating for half the time. So I can play with that if, for example, I need, maybe I've got more torque available, but I want to move faster. I may go to a triangular profile, things like that. As far as the smoothness goes, right now, basically there's no smoothness as default, but if I wanted to actually put in some S-curve acceleration, so I'm going to ramp the acceleration, you can see I've kind of smoothed it out when it's starting and stopping, and it gives you a 40% jerk for accel and decel. If I want to go to maximum, I go there and put in 100% S-curve, which would be the worst case, right? So if you're sizing, this is also important. So if you understand, the programming, whoever's going to be doing the programming, they should be able to, you want to compare and make sure that whatever you sized for how it got from point A to point B is going to match up in your program. So for example, if I'm in here programming this without S-curve, and I just go ahead and put 0, and then later on the programmer puts in some S-curve in there. Well, it may require more torque to use S-curve type of acceleration than it would off a standard type of trapezoidal move. So again, I'm just going to go ahead and put some standard and use the 40% for this exercise. So I've gone ahead and put that in. If I had some dwell time, say for example, the application said no dwell time, but say for example, they had a stop and maybe there was some assembly requirement or something, other operation that was going to be done on the index conveyor, then I would actually go ahead and put the dwell time here. And I can insert, cut, copy, paste segments. So depending on what comes first, second, third, I can go ahead and change this however I need to. But for example, here, maybe I'll put in just say 0.2 second dwell time. So you can see I've got my move. It's taken 1 second, and I've got my dwell time 0.2. So my total cycle time is 1.2 seconds. You can see there. Now the next step in the profile editor is that I have to add. I could add the mass here, or I can also add it in the mechanism. But right now I'm going to probably just say, yeah, I want to add the load, right? So again, we're starting on the output, and then we're working our way back towards where the motor is. So the first thing I'm going to do is say I've got a constant load. So here you got a variable load. It defaults to. And basically here it would actually, you can have the starting mass, and if it changes, you could have it, maybe the mass gets lowered as it moves or something. You get an application like that. But in this example, I'm just going to say I've got a constant mass, and I got to go back and look and see what the application told me. It said that the load weight was 100 pounds, right? So I'm going to go in here, and I'm going to put the 100 pounds of mass in here. Now you can also change your units here. You can see I've got pounds, ounces, grams, kilograms. It'll automatically convert it for me. So if I wanted to enter that in kilograms, or depending on whatever units you're working in, you can change it here. And then once I've gone ahead and say I've entered that in, the other thing over here, you have you're starting your initial conditions. So I'm saying that my application starting at 0 velocity, my initial position is 0, and my incline is 0. Now, if I had a vertical axis or something other than 0 degrees horizontal, I would enter that here. I'd maybe put in 90 degree, and we can maybe go back and try that later and see how that changes things. But once I've gone ahead, the other thing I have to do is the coefficient of friction. So there's force. If I had an external force that was on the application, like a spring or something that I was going up against, or maybe a seal bar application, you'd have some external force. You may have that just at the last part of the segment. So you may say, okay, I may move most of the position out, and then at the final inch or two is when I'm going to experience external force. So I can really get detailed in the profile editor, and really the more detail I add to this, the better my sizing is going to be. So the other thing is the coefficient of friction. So when I go back and I take a look at my application again, I looked here, and the coefficient of friction was 0.1. So I would go ahead and add my coefficient of friction at this point. And again, it says variable. You can make it per segment. I'm just going to say I want it constant. The friction is going to be there the whole time for the full move and dwell and everything. So once I'm done at this point, then I've got my move time in here. I've got my mass. I've got everything that I need, and you can see all my motion down here. You can see everything here. If I need to cut something, I have the ability to cut a segment out, or if I want to copy, maybe I have multiple moves that I want to paste. I can copy a segment and then paste it. You can delete something if something's changed or you don't want that in there, and you can also undo as well. So once I'm done with this segment, you can also clear it out. Say you want to start over again and just and start from the beginning. You can just clear. It would clear everything out at this point. So once I'm done with this part, I would go to the next step. I've got my profile editor in here. Now at this point, I've got my position. I've got a dwell time I put in here. I put my mass in here. So I'm ready to go to the next step, I think, at this point. So the next step now, basically, again, if you start looking at the workflow, next thing it's going to ask me is what my mechanism type is. So the mechanism type that I have for this particular application, I have integrated actuator. So this would be like a rod style type of actuator that I could use. Linear servo motors if I had a linear application with that, again, as I mentioned. In this case, I've got a custom mechanism, right? This is not something that I'm going to buy off the shelf. This is something that an OEM or somebody's providing. So now I would go in and give it the mechanism type. So down below then, it opens up the different types that are available. So I have either a lead screw, a belt drive, chain and sprocket, and rack and pinion. In this particular application, it is a belt drive. So I'm going to go ahead and select belt drive. And then once I go ahead and select the belt drive, I can give it a name if I want to say, okay, that's conveyor, maybe conveyor 1. And again, I could have put the table mass here in the belt mass. I did have a belt mass, right? So when I did go here, there was a belt weight of 36 pounds. So I want to put that, I'm going to enter that here. And then down below, it kind of defaults, put some parameters in here for the diameter and the inertias and things like that. So this is where you actually go in and give it the dimensions for the driver. And over on the right, you'll see a picture here. It kind of gives you the driver, it gives you the idlers, so you can kind of see, okay, there's the load, there's the table. So you can kind of understand the different components if you're confused at all on what they're asking for here. But again, if I go back to my application information that the customer gave me, I could see that, okay, I've got a pulley diameter shown here, a 3-inch, and it's times a 2-inch solid aluminum. So it's a 3-inch diameter, 2 inches wide, and it's solid aluminum. And then the idler pulley is the same as the main pulley. So I've got 2 pulleys. So I'm going to go in here and I'm going to put in my 3-inch, and then I've got the inertia calculator here. So a lot of times customers don't understand or don't have the inertia. They may not have the inertia of the component. So the inertia calculator comes in, is very handy for the application. So in this point here, I'm going to say, okay, I've got a solid cylinder, and I'm going to basically model the belt pulley. So I'm going to say, okay, again, it's a 3-inch by 2-inch. Oh, and then the material type, I'd have all the different material types here. So whether it's steel, silicon, rubber, wood, my pulley is actually going to be made out of aluminum. So at this point, I can go ahead and add this. If I want to give it a name, I can just say main pulley. And then I can just say add that there, and there it shows up there. There's the inertia. And then I say apply. And when I hit apply, it basically puts it right in the box here for me. I don't have to retype that in. And then here I could go back in and do another one. But since I already know, okay, the idler's the same, I can just go in and type the inertia for the idler roll. And, I'd say that there's 2 rollers, and, there may be some friction torque that you have to put in here. Let's see here. I should be okay at this point. Go there. Yeah, I think I'm okay here. So I think I've got everything. If the idler rolls count value is required. So there you go. I didn't have, see down below, you'll see a little red fault here. So if I don't have everything up, it grays out the add mechanism. So at this point, I've got to tell it how many idler rollers I got, right? So it's wanting to know that. Once I've got that information in there, that looks good. For some reason, I put that back to 39 inches. So I'll make sure I just go put that back to 3. Say add mechanism, update mechanism, and I should be good at this point. If for this part of it. So I've defined my mechanism for this application. Now, the next step would be if I had a transmission. For example, I may have a pulley reduction, or I may need to add a gearbox. Now, typically with a conveyor indexing type of application, you are going to probably need a conveyor. You're not going to, you could try to do it with a direct drive, but you may end up with a fairly substantial size drive and motor. So in a lot of cases, we take advantage of the mechanical advantage with the gearbox. And as long as we've got enough speed and like that, we can use a gear reducer. And now if I go into the gearbox type, you'll see down below here, it'll give me all the different type of gearboxes. And I can either go ahead, if I kind of know which type of gearbox I want, I can go to table view, and I can maybe type in something like a VRL or something like that, and then all the styles of that series gearbox would come up if I'm familiar with the part numbers. Otherwise, if I'm not, I can kind of look at the pictures and say, okay, that looks like an inline gearbox. There's a right angle gearbox. Or definitely just reach out to us and we can help you with that as well. At Revere, we're familiar with all these different guys. We can buy and resell all these gearboxes as well for the applications. So, for example, here I may just go in and say I want just a value line. I don't really care about the backlash that much. Just kind of want a standard gear reduction inline. If I find out later on that, hey, I have some space constraints, the motor's sticking out too far, I may want to go to something more like a right angle down below here, And there's also 2 pages. So if you don't see the particular type of gearbox that you're looking for here, make sure you go to the second page and it'll show you all the different type of gearboxes here. So for example, we sell a lot of these K boxes. I may want to use a right angle or an offset gearbox where I want to tuck the motor back underneath the conveyor. So there's a lot of different options that we have for gear reducers. But for today's exercise, again, I'm just going to click on NP and say, okay, that looks good to me. You also see there's like a little info button here. So if you're not familiar with the gearbox, it'll kind of tell you, okay, this is a value line alpha gearbox, and it's ideal for mid-range applications, right, with the shaft output. And then if you want, and actually take you to that link. So if I say, okay, I want to know more information, I want technical data, I want drawings, information for that gearbox, I could go ahead and click on that, and it'll actually take me to the manufacturer's website to get more additional information for that gearbox. I may be concerned about the radial loading or the axial loading specs that are outside of this application here that would not be included in the FTMA. So at that point, I've got my gearbox. I've got, so my next step is basically adding the motor. So if I go here and I take a look, I've got options, either put a custom style motor, but I'm going to look at, again, the standard off-the-shelf type of motors that are available from Rockwell. So I come in and I can see I've got all the standard black painted motors. Now the VPL, this is basically a single cable option. This is used quite often. We size a lot of these motors here. The predecessor to that was the MPL motor. We still sell quite a few of these as well, depending on the application and what the drive is. In some cases, we have to use the MPL. And then if you look down, we also have large motors for very high performance applications, high horsepower. We've got food grade motors. So if I have an application that's maybe in a food grade environment, you'd want to look at a VPF motor. If you had like a continuous duty motor for like a web handling application or something like that, you would look at VPC motors. So there's all different type of motors in here, depending on what your application requirements are. If I got into a washdown application, there's a lot of Rockwell does a lot with washdown as well. We have the MPS series or the VPSs, and if I need like something with a hygienic type of design, I would look at the VPH motors. So again, there's quite a lot of options here. If you need some lower cost value style motors, there's also these TLPs or TL style motors. So again, you can see here's an explosion proof motor. If my application requires explosion proof. So it really just depends on the application. Again, you know, if you get into something and you're going to try to do the sizing, feel free to reach out to a specialist, and we'll more than happy to help you with the sizing and the selection for this. So at this point, I'm going to just say, okay, this is a standard application, and I'm just going to use a regular black paint motor, VPL motor. So at that point, what you've got to do, you got a bar slider over here, and sometimes you don't see, you kind of got to pull it all the way over to the right, but then you'll see there's a drive option here. So my next step is, okay, I've got the VPL motor selected. I've got my gearbox selected. I think I know what I want for the base components. Now I'm going to look at the drive. So I have to kind of know what the voltage is in the plant that I'm working with. So most common we size is a 460 volt 3-phase, you know, but if it's 220 or something like that. And then the selection will tell you what drives based on what you're selecting for voltage, what drives, you know, fit in that class of voltage. So for example, I select 460. I could either use the on-machine Armor Kinetics. I have options for Kinetics 5700 drive, or I have a Kinetics 5500. So right now with that VPL motor, I'm going to say that I'm going to use, the customer wants to go with 5500, which is a very common drive that we sell a lot of. So at this point, I've got told the software what my load is, what my transmission, my mechanism type. I've given it the gearbox. I've given it you know, the motor and the drive and everything I want to use. So if everything it checks out good at this point, I'm going to go ahead and go to the solution search here. And when I do this, it's going to ask me if I want to save the project. And I'm going to say, yeah, let's do that. And instead of the default name, I can go ahead and give it a name I want to use, conveyor application or whatever. So I would just go ahead, give me some kind of reference so I can remember what this is. And I'm going to go ahead now and save it. Now what the software is actually doing, it's going out based on all the parameters, the information that I gave it. It's going to go through, and hopefully if I've put everything in there and there's and you know the requirements are not viable, then it will come up with the solutions. If I put something in there that's bogus, like maybe I put in 1,000 pounds instead of 100, or I put in something, the idler, I fat fingered 30 inches instead of 3 inches, you know, you may come in here and see that it's going to say no solutions found, you know, and so then you may have to go back into your application. It doesn't necessarily tell you what is the issue. But you'll have to try to go back and just verify everything. And again, if you get stuck, you can also email these files to us, and we can check them out as well. So right now you see I've got basically the solution search here, and you can see how many different applications it's come up with a lot. So this is a good thing, good problem to have, that I've got a lot of different options to look at. So what it does is it tries to match up the highest first. So it's saying, okay, the first one is showing, this is my drive size, 2198. That's the part number. That's the motor. And then it's come up with the NP025. This is the gearbox size. And the ratio in there is just from the part numbers, -7 is a 7-to-1 ratio. Now, if I start looking over and go, well, that all looks really good. I don't see no problems here from torque and a speed point and, you know, what we're looking at from a servo sizing. But I may want to say, oh, that 24-to-1 is kind of high in my eyes. I probably want something under 10-to-1 maybe that I want for an application. Typically, when we look at inertia mismatches, we prefer something probably with a little bit lower. Now, I can actually sort these by any way I want. So if I can either sort it by the smallest drive or the largest drive, and in this case, I'm going to start with the smallest drive. Here, back up again. Yeah, go back that way. And then I might want to take a look here, and I see the ratio's high. But what I want to probably do is get down below, uh, you know, the 25-to-1. That's probably just too high. So I can take a look here. There's some smaller motors that are available down here with a higher ratio. This is actually not bad at 10-to-1. The other thing you got to keep in mind is the gearbox pricing, and the cost for gearboxes. They they can vary widely. But typically we'll look at like a single stage gearbox up to a 10-to-1 ratio. And then over and beyond that, we've got to go to a two-stage gearbox. So I try to take advantage of a single stage as much as I can and try to stick with the single stage because that's going to be my highest reduction for a single stage box is the 10-to-1. So what I'll do there, and then look at my inertia mismatch. Okay, 10-to-1, I'm just over, but for this application, it's not that critical. So maybe that's probably going to work fine. So at this point, I'm just going to say next step, and I'll try to take a look at that solution and see if I like that one. Now, as you notice on the left side here, you can see my workflow. So you can see I've got green checks on my motion definition. My components are checked green. My solution search is green, and now my analysis is green. So this is, again, the workflow that we use. And I can see here that this motor and drive. Now, what this gives you here is a torque speed curve of that motor and that drive combination. So if I take a look here, I can kind of scroll over and take a look here. I can see there's the drive capacity. Everything is in green, which is good. So you want your green bars to always be in green, not yellow or red. If you're in red or something, you've got a problem. So you can see right now this drive looks pretty good size. I don't see no problems here with the drive sizing. Thermal capacity on the motor looks good, so the motor should run nice and cool. I've got my peak speeds, my peak torques, and everything looks fine. So when I look at the servo sizing and I look at the speed torque curve, the servo motor basically gives you a couple different curves. The yellow line basically is the continuous torque curve of the motor, and that's where the motor can run all day long, at a certain temperature, and your torques can run underneath that curve, just fine. The zone above the yellow line is called more like your intermittent zone. So for like brief accelerations or decelerations, the servo motor can operate, above 100%, 200, 300% for a brief period of time. However, if you start doing that too often, what will happen is that your RMS torque will start going up on the application. So if we start looking, we see these green dots and these yellow dots, they represent, basically the green dots represent, the peak forces, the peak torques of the application. So I can see that I do have a couple green dots that are above this motor's rated in Newton meters over on the y-axis. I can see that I've got 2 Newton meters is relatively the continuous torque just below 2, and I've got a couple dots there probably during the acceleration that's causing those to go above the continuous torque of the motor, which is fine. Because if I look at my yellow dot, that's the RMS torque for the application, and that's basically below the yellow line, and how much below it is my safety factor. So I can see that I'm not very close to the yellow line. I'm about 75%. I'm 25% on the way away from that yellow line. So I've got a pretty good comfort factor here that this motor and drive is going to work for the application, and the sizing looks fine to me. So this would be a viable option that we could go ahead and look at. So we're basically looking at this particular size planetary gearbox, 10-to-1, with a VPL 100 motor, single stack motor, and Kinetics 5500 drive. So at this point, everything looks fine to me. So then the next step would be is to, if I want to go from this point, I want to take a look at the power analysis next. So I would do here is go back to my architecture overview, and what I need to do is add a bus. So at this point, what I'm going to do is add the bus in here. I'm going to go ahead and put in, 460 3-phase, and then in here, basically the drive, I have to kind of say, okay, because you could have multiple drives, multiple buses in the application. It can be a very large application. So in this particular point, I'm going to go ahead and say I want to go ahead and add this to the bus. So I'm going to add that to the power bus. And now I've got the power bus in there, and I got the index conveyor in there. And now I want to do the power analysis. So I'm going to go ahead and it asks me to save again. And I say, okay, that looks great. And what it'll do real quick is go through and then show you your aggregate power for the application. So you can see how much power I'm using. You can see during the acceleration, about 900 watts of power. So, and then, basically the power calculation consumption overall down below. So the next thing I would do is check here. This is pretty important that, especially if you have a vertical axis and overhauling load, you have to be concerned of regen. So here I basically go ahead, and I've got it on auto right now. So I'm just going to have it go ahead and see if it can go through and give me a calculation here. So it's gone through now and it's checking if I need a shunt or capacitor module. But you can take a look, and this is actually showing like what the bus would look like, the voltage and current going out to the motor. And then, this showing the bus voltage, the continuous current, the peak current, and the shunt. So the shunt here is still in green, which is a good thing. If I was to go back and go in that profile editor and say, okay, this is a 90-degree index conveyor, you're going to see erratically, it's going to get it much higher, and probably going to tell me I need a shunt for sure. So at this point, everything looks good. I got my my power supply and everything, sizing looks good. So then the next thing here is I can go in and I would actually see, this would be my bill of material. I could go ahead and export this to a CSV file and give me this. I can also then take this, again, as I mentioned, I can import the, I can save this as an XML file if I want to save this. And I can go ahead and import that to the online tool, fill out all my cables and the motor options, whether I want a keyway or smooth shaft, whether I want a holding brake. So all the different options for the motor and the drive, what safety options, things like that. I want to finish the drive part number out. And then I can import that to Proposal Works and get a complete, bill of material as well. So at this point, I look pretty good here. Go back to Architecture Overview, and I want to save this. And then here I can actually import or export to file. So if I wanted to export the file, I could just give it a name here, conveyor, conveyor 1, and maybe hit save. And now I've successfully exported this, and I've got a saved file of this. So I can now email this to a customer or to somebody else, whoever I want to send this to, or they can send me a file if I need to as well. So at this point, I've kind of gone through the sizing for one axis. If there's any questions, we've got about 5 minutes left here. Feel free to ask any questions at this time.
There are currently no questions in the chat, John.
Okay.
So
at this point, if there's no other questions, like I said, if something comes up later, feel free to reach out to us as well. And we're more than here to help you for any of your motion applications.